is 1 to 2, what a lot of people are going to do, double these. They're going to take them each times 2. Those are wrong. That is not how you do that. That is the geometry mistake that a lot of people make and why they get these problems wrong. And if this is on a multiple choice test, you're going to see these answers here because they're going to try to bait you into choosing them. It doesn't get focused on as much as I think it should, considering it almost always shows up on a final, on a geometry EOC, SATs, and ACTs. I'm going to show you a shortcut that makes this really easy, and you do not need the formulas for surface area and volume. And calculating surface area is definitely not a fun thing to do, but we don't need to. Somebody's already done that for us. You just have to remember this. When they're talking about scale factor, they're talking about the scale factor in lengths. Like if you knew the radius of this one would be twice as big, like a line. The height would be 1 to 2. But when you start moving into area, the units are squared units, centimeters squared, and the volume is cubic units, centimeters cubed. These powers are what you need to do to adjust your scale factor for areas and for volumes. Let me show you. So if we're going to go for areas first, when you are going to do scale factor of areas, you start with the scale factor that you're given. Areas are squared units, so square both of these numbers, and your new scale factor is going to be 1 squared to 2 squared. So for these numbers, you don't multiply by 2, you have to multiply by 4. Well, not those numbers, just the area number. So let's get that surface area. We had 28 pi. I'm just going to take the 28 and I'm going to take that times 4. And we get 112. So this was supposed to be 112 pi centimeters squared. That is the surface area for the larger cylinder. Okay, so that is for areas. And if we're going to do the same thing for volumes, scale factor volumes, and you have to do this each time you have your scale factor given to you, 1 to 2. But now, since volumes are in cubic units, you want to cube each one of these numbers. So we ended up with 1, 2, 8. So this number, instead of being 40 pi, we need to take this one times 8. I can do that in my head. So that would have been 160 cubic centimeters. And so that worked with cylinders. Let's do it again. This time we're going to do pyramids. The scale factor is 1 to 3. So for the area, it's going to be your area scale factor is going to be squaring those. So it's going to be 1 squared to 3 squared, which would be 1 to 9. So I need to take this times 9. 360 times 9. 3240. And it's in inches squared. Now we have to do scale factor for volumes. So again, we're starting with the 1 to 3. That's the original scale factor, but volumes are cubed. You can see that from the units. So cube that up. And you are going to end up with 1 cubed is 1, 3 cubed is 3 times 3 times 3, 9 times 3 is 27. So we're going to take our 400 inches cubed times 27. That would be 10,800 cubic inches. Now test yourself and see if you have learned that trick and that you are going to be the one who gets these right.